Today we are talking about the popular Gen AI design pattern called RAG. So here we go. Have you ever written an exam where you didn't study that one topic and then the question shows up on the exam paper? If you're like me, you just try to write something smart and pray for the best. And sometimes I got lucky, but most times I failed because I wasn't recalling facts, I was just confidently guessing. And this is exactly what LLMs do when they hallucinate or something similar to it. As powerful as they are, they only know what they were trained on. So let's imagine a scenario. Imagine you're building an AI app for your company. Let's call the app Mira. Mira is designed to help employees find answers fast. So employees can ask questions like, what's our travel expense policy? How do I reset my laptop password? And several other questions like that. Mira always responds because it's connected to an LLM, right? But sometimes it's just completely wrong. And it makes sense, right? It's not wrong necessarily because the LLM is broken, but because out of the box, LLMs have no access to your company's internal data. So things in this instance like your HR policies, your IT guides, or even your process documents. So when someone asks any question about those, Mira will just guess or say it doesn't know. So kind of like that exam where you didn't study the right books in the first place. So it begs the question, how can we help an AI app like Mira answer questions it was never trained on? And this is where that simple but powerful design pattern comes in, Retrieval Augmented Generation, or RAG. One way to think of RAG in this context is giving Mira an open book exam instead of the closed book one, which means instead of relying on its memory or what it has learned before, the LLM can now open the textbook, which in this case will be your data, find the right information, and use that to write a better answer. Sounds good. Now, to be clear, RAG is not a new tool or language. It's a design pattern. And it essentially combines the stage of retrieving relevant information from your data and generating an answer using that information. So, how does it work conceptually? Let's break it down into a few easy steps. Let's start from the first step, retrieve. When an employee asks a question, the first thing Mira will do in this instance is it will search all your connected data sources, your HR docs, policies, reports, to find relevant passages. And it doesn't just match based on keywords. It uses something called semantic search that I will explain shortly to find text that's close in meaning. Step 2, augment. Now, those retrieved snippets or information is now attached with the user's original question and sent to the model as extra context. Step 3 is generate. The model uses both that question and the retrieved data to produce a fluent, accurate answer, but this is done in real time. And that's the magic of RAG, from query to retrieve to augment to generate. Now, you might wonder, when the user asks a question, how does Mira find the relevant pieces of information to retrieve in the very first place, right? So, if we were using the open book exam analogy, how would we find the right page which has the answer? And this is where one of the most popular ways to solve this comes in, vector databases. Now, I could do another video on vector databases, so let me know, but this is an overview. You can think of vector database as a semantic search engine, or if you like analogies like me, like Spotify for text. Hear me out first of all. When you search for a song on Spotify, it doesn't just look for exact titles. It sometimes suggests other songs that have a similar vibe, even if they're from a different artist or genre. So in the same way, when your AI app receives a question, the database has to retrieve text chunks that are close in meaning, even if the exact wording is different. And this is where vector DBs shine. So how do they actually work under the hood? Before you wire up your system and all of that stuff, or make it open to your users, you start by gathering all the documents relevant to your app or system. So in this case for Mira, things like I said earlier, like your HR documents, internal PDFs, etc. Now you get those documents and you split them into smaller parts using a technique called chunking. I'll explain why you split them shortly. Each chunk is then converted into an embedding, which is essentially is a vector or a list of numbers that captures the meaning of that chunk, because you have to remember computers only understand numbers, not text. And this is so that when a question or query comes in from your user or employee, the question is embedded and the system can then look for chunks whose embeddings are closest in meaning or closest in vector space to the user's question, which is what we mean by semantic similarity. This is basically how the system figures out which pages in your textbook are most relevant before it generates the answer. And with RAG, you've got three main benefits. The first one is a bit obvious. So your AI app's answers become grounded based on real data you have. But two, it's also traceable because you can see which document was used to answer the question. And three, it's scalable. So you can add new data anytime without having to retrain the model from scratch. Now, as brilliant as RAG sounds, it's not a silver bullet. If your company's data is outdated, your model's answers will be too. So you have to re-embed documents and keep your data fresh. And also, models can only read so much text at once, which is called the context window, which is one of the reasons why we chunk. Good RAG systems balance relevance with context size and data freshness carefully. So there you have it. This is RAG in under 7 minutes or so. Of course, it's it's just an overview. But here's the bottom line. If you're building with LLMs, RAG can turn your model from a confident guesser into a grounded expert that can cite its sources. If this clicked for you, follow for more AI breakdowns like this, one story at a time, and drop a comment. What would you build with RAG? I'm really curious to know what problems you're solving. Until next time, thanks everyone, and see you later.